Hello, everybody. Yeah, Nathan Armstrong here from sunny, just outside of Calgary, up in Canada, where we have we call it West Coast North facility, where we have a composite shop, R&D shop, test track, and a few of the neat facilities up here. I'm actually CTO for Aptera. I've been with the company since the very beginning, back in 2003, when we tried this the first time. Yeah, I'm very familiar with the vehicle, very familiar with the story. My background is I was an aerospace engineer initially. Then I got a job for a company called Metal Crafters in California, where we made concept vehicles for the major OEMs. So I started out in like '96 as like the mechanical engineer. That really annoyed all the old craftsmen that was in there. It was like the young CAD guy that came in and kind of like, caused a lot of problems for the existing trades. But we started building concept cars, designing them on the computer. Did that for 15 years, building concept cars, and then I had my own company doing vehicle design, development, and now with Aptera, mostly full time. So I've done about 100 vehicles, various concepts over the years, and a whole bunch of electric ones. So if you got any questions about any weird electric vehicles in the past, I might have had a hand in them. And I can give you guys a bit of the history if you want, of kind of like how the Aptera kind of came to be. And I got some other interesting stories like around the Volvo 3CC, some of the vehicles that we did back in the early 2000s that you might find interesting. But the suggestion from the Aptera crew was to just open this up to questions right away, and let's just kind of get into a bit of a story and so we can dig up.
Would it be possible, because I think a lot of people have never seen this vehicle before. Would it be possible to do you have like a video or something that you could show us as a start?
I talked to Sarah about that, and she said the best place to go is actually the Aptera YouTube channel, because we keep posting a bunch of stuff there. So if you want, I can pull up some videos and share my screen. We had one at the test track the other week that was pretty good. So I don't know if you guys have seen any of those videos. We could show a video, or you guys could just look at it on your own time kind of thing. What do you prefer?
Why don't we just start out by showing it, just so that people, once they see it, I think that will elicit some questions for people who haven't seen it before.
Sure. I'm gonna get commercials here. You guys see that? Yep. All right, so this was at the test track about 2 weeks ago. We're just doing quarter-mile tests, and we're doing moose tests, and we're doing all that kind of stuff. So this is prototype number 1 of what we're calling the alpha design, which we started in late 2019 and finished building that vehicle middle of last year. We're getting great performance. It's an evolution from the vehicles that we did 10 years ago, 13 years ago. So we weren't expecting many surprises. The main difference between this one and the last one is we're using in-wheel motors this time, which is an incredible thing to be using. Anyways, that's the vehicle. It's kind of a strange looking thing. It's basically based on Steve Fambro, who was the founder of the company. He was inspired by sharks. And now sharks, when they come down to the ocean floor, they actually have to arch their backs up to overcome the ground effect, and it allows the water to go underneath the shark's body. So it's basically like a cambered airfoil. But Steve kind of figured if this was the most optimal shape, like why not design a car using like the most optimal shape possible? And that's where the original design came from, and it's evolved throughout the years, and it's gotten a bit bigger and a bit fatter to fit more batteries and a bit longer. And but we've always maintained the coefficient of drag. We're at like 0.128 now. The first car was 0.09, which was less drag than a 12-inch cube. And the other one we like to reference was less drag than a windshield wipers on a typical vehicle. The goal was always to create the most efficient, lightweight, safe vehicle possible, kind of thing. So that's the Aptera.
So how does it get the 1,000-mile range, what goes into that?
Well, the vehicle itself obviously is super efficient, right? Like we're getting 1,000 miles on the same size battery pack that a Tesla Model 3 is getting, 400 miles on, just because of the efficiency of the vehicle. So it all comes down to lightweight aerodynamics and using power efficiently, right? So we've got very smart systems around regen. With the in-wheel motors, we can capture a bit more than a regular EV. Yeah, no, it's just. I mean, the whole vehicle weighs 1,600 pounds. It's incredibly lightweight. It's basically like an airplane with wheels, but a very advanced structural monocoque. We use a multi-piece construction where we end up with like this beam system around the cabin, and then we inject foam into all that. So it basically becomes like a big motorcycle helmet when it's done. And when we tested the cars years ago on the crush test jig, we were 6 times above the vehicle weight, which was a record for vehicles at the time. And the spec is 1.5 times vehicle weight. So it's extremely strong. And the other big breakthrough that we found was when we compressed the body. So we had it on a big fixture with a big plunger that cracked the body in. When we cracked the body in, we got the force reading, then we pulled the plunger back. The whole body like popped back out, like the whole thing returned back to its original shape. And that was a really huge moment for us, because that means from a safety perspective, not only can you control the energy absorption and you can direct where it goes, but then after the impact, it's going to return back, which means you're not left squashed in a, you're not crumpled up inside a car kind of thing. So from a safety perspective, that's a massive breakthrough. We feel that you're not going to have these issues. And of course, it's resistant to hail, and it's resistant to, rust. It'll never rust. We're essentially designing the main monocoque to last indefinitely. So the goal is that the vehicle will last, give it to your grandkids kind of thing. And then we're using a lot of natural fiber-based materials for the body panels that are going to get broken, like the skirts that are going to get impacted. And we're using natural materials in the interior that are also biodegradable. So every 5 years or so, you could do a refresh on your car, get a new interior, get some new panels put on kind of thing. But the main monocoque is designed to last forever. Sandy Munro is still affiliated, yes. They actually invested in the company. And we're working closely with those guys to bring it. Yes, we do have airbags, actually. We have airbags in the seat belts, which is a vehicle-approved method of doing seat belts for a low-volume manufacturer. So we have airbags.
So in a crash, are certain components designed to crush to absorb energy so that you're not transferring momentum to the passengers?
Mm-hmm. Yeah, in the front, we got a traditional kind of subframe with a crush tube structure, with a traditional kind of a bumper. So on a front impact, it's more like a regular car. And then the rest of the vehicle, the side impact is all composite. The rear is all composite, but it's all tuned to, like I say, take the load and distribute it around the body in a way that's controlled. And very effective. Like it's an extremely effective, safe monocoque. It's more like a race car kind of thing than a regular vehicle. Yeah, service. So we're a big fan of ride to repair. Like we're all mechanics, we're all hobbyists, we're all tinkerers, right? We're all crazy, whatever guys. So we all like working on our own cars, and we don't agree with this like not ride to repair thing. We're making the car as accessible as anybody wants it to be. So depending on how deep you want to get into the vehicle and play with the systems, it's all available. The plan for service is something kind of like Tesla has, where bands will come out and do kind of things. But we also want to promote self-service. We want to promote people fixing their own vehicles if they can. If it's something simple like a door handle, or something like a wiper arm or something like that, it's a very easy fix. And even more complex mechanical systems like the getting into suspensions and stuff, like the vehicle is very simple. I think people are going to be surprised how, how basic it is, and not from a basic because it's like not well thought out, but basic because we're kind of following the Lotus ethos, right? Simplicity, lightweight, reduced part count. So it's going to be a very accessible vehicle to work on, and we really think that people will, tweak them and tune them and have some fun with them, right? That's kind of the idea.
So how close are you to actually getting into manufacturing?
Well, the plan is to build a limited number in January that are going to be for the public, and then a larger number in February, and then an even larger number in March, and then by June we'll be in full production. That's the plan. So it'll be a vehicle every 3 minutes by June. Until then, we are going to be delivering customer vehicles in January. So that was the promise, and we are going to follow through on that. So But no, this is the crazy time right now. Like it's 24/7, and everybody's jumped through every hoop you can imagine. And we got new people joining the team. We're getting exceptional people joining the team. A lot of aerospace guys, a lot of guys on really interesting projects in the past that are coming to the team because they're really passionate about this project and how it's going to go. So that's been amazing, actually. How are the seats for long distance driving? They're great. They're 6'6" is what we are designing for. So a 105th percentile male is the largest. The battery cooling system's a fun one. So Steve is a aerospace guy. He was a pilot, and he's got big into skin cooling. So we've got this crazy system of channels laid into the belly pan. Basically we run the fluid through that, and then we've got a surface coating that transfers the heat into the composite, and we're actually able to transfer enough heat out through the skin to cool the batteries. So it's a skin cooling process that we're using. So it's aircraft technology. There's an interesting question on the uphill thing there. Again, the lightweight works in our favor here, right? I mean, with one passenger, you're going to be 2,000 pounds. Going up a hill, you're not going to have the same pull from gravity as with a 5,000 pound vehicle, obviously. So, but we'll have to quantify that, see what that works out to.
I'm going to go back. There were some questions in chat earlier, and I just don't want to miss them. So one person was just trying to confirm, when you say 1,000-mile range, do you mean one could drive 1,000 miles nonstop?
Mm-hmm. You know, that was one of the crazy breakthroughs back in, I guess, the end of 2019, early 2020. We started looking more seriously at packaging batteries and how we're going to package the batteries and how we're going to package enough batteries. And the beta car that you're going to see coming out, even later this year, September, October, we'll see the first examples of the final design come out, and you'll see the belly's a little bit bigger than the current vehicle to fit more batteries. But it was just a matter of, okay, so we can fit this many batteries, and then you run the calculations through our efficiency calculator, and it turned out the range was about 1,000 miles. Like it was just one of those things when we plugged the numbers into the simulator, and it was like, wow, that's crazy, you know, that's really crazy. Like that's it really. And then we ran it again and again, and it was like, yeah. So it just comes purely down to how efficient the vehicle is. Like it's not a huge battery pack to get that kind of range. So
may I just ask a follow-up? So the efficiency, can you measure it in miles per kilowatt hour, or you know, how many kilowatts
yes.
the battery has?
Yes, and I could give you the number, but it's a moving number at this point, and not something we really want to share. But it's it's a fraction of a regular vehicle. Like it really is an astonishing orders of magnitude more efficient than a regular vehicle. It's more efficient than riding a bicycle, put it that way, for a calorie per mile usage. It's so.
Why 3 wheels? Just to make it light and less tire cost?
No, actually, it was purely a chase to be the most efficient vehicle possible. So obviously, 3 wheels, you have less rolling resistance than with 4. Aerodynamically, it's not that much of improvement, because with the 4 wheel, you put the other wheels, like the rear wheels, are behind the front wheels, kind of shadowed. But from a rolling resistance standpoint, it's a huge gain, and then from a brake drag standpoint, it's a huge gain. So that was kind of the main thing. And then of course it's an easier market to get into. So we registered as an motorcycle right now. So you can ride the vehicle with a motorcycle license. But it was mainly due to creating a vehicle that we felt was the benchmark in efficiency, right? Like this really is like it's an example of what could be done kind of thing. Like we don't think it's the most efficient from a passenger standpoint. Obviously it's only 2 seats. 4-passenger vehicle will be more efficient. 4 wheels is more kind of mainstream, so 3 wheels can have less acceptance into the market. But we felt we wanted to make a statement. We wanted to show how, you know, through intelligent design and through intelligent use of materials and whatnot, you could actually achieve an orders of magnitude improvement over efficiency than anything on the road today. And we just felt there was a massive low-hanging fruit that someone had to pick. I mean, as cars get heavier and heavier, it just seems to be going in the wrong direction. So, so the next vehicle after this one is going to be a 4-wheel vehicle, 4-passenger vehicle, but using the same principles of lightweight aerodynamics and all that kind of stuff. Lithium ion, yes.
Are there any plans to have a smaller battery pack? Obviously, that much range is really not necessary. Even the current EVs of today probably really don't need it. So what's your thought on that?
Oh no, we got 3 different packs. We got a 350-mile pack, I think 600 and then 1,000, something like that. But of course, as you get lighter, as you put a 300-mile pack in, your efficiencies go up, right? Because your battery pack is a third of the weight, and of course, everything gets lighter and more efficient. So, you know, it's one of the things where the lighter pack actually, it's not that you get less range, right? Because now you have less weight. So,
yeah, no, that's kind of what I was thinking. Is
Yeah.
back to our American everything bigger. It doesn't always have to go that way. So that's great to hear. Thanks.
And then with the solar panels, of course, we're getting it's 35 to 45 miles a day of charging in ideal conditions, right? So that's that was another one of those things that we looked at the solar panels and we said, well, it's a bit, you know, like the solar car stuff. I mean, it's like, you know, it's great and it's fantastic and we all love it, but does it have a practical application? And on the very first car, we had a solar panel and all it did was recirculate air into the windshield. So like from a climate perspective, all your heat absorption and interior comes into the windshield. So if you just create an air pocket there, you stop that radiation coming in. So we had a solar panel just to run a little fan to make this like heat curtain kind of thing. But then other guys were coming out, the Fisker came out and they're like, oh, with solar panels you can charge the car with. And it was just a joke, right? So we're like, we got to be really careful about what we say about solar panels because it's like, you know, we could backfire. But then we set up an experiment and we ran it running for 6 months and we did the numbers and it was like 40 to 50 miles a day of charge time. That's like 2 gallons of gas in your car when you come out from work. That's magically in your tank. So we felt, you know, for the cost impact, it's a few $100 per vehicle. There's a bit of a technology challenge, like getting the panels to infuse with a composite. And we're working on 3 different ideas how to do that right now. But we're really hoping like the solar film technology or like the nanodot technology gets going because working with the cells now is a bit of a pain. But the end result is you get a significant amount of charge. So it's worth it, right? And it's really not a weight penalty. So handlebar or steering wheel, conventional. It's a normal sort of looking interior. 700.
What about crosswinds? I picture myself driving from Denver to Santa Fe. You hit those flat areas in New Mexico. You're doing 70, 75 miles an hour. It's maybe on the slower end. And you get a nice little crosswind. And the car looks very aerodynamic. Do I need to worry about getting blown off the road or anything?
Absolutely not. No, it works the other way. I mean, the car's aerodynamic in every direction. So crosswinds.
Yeah. Makes
like
sense.
when we went out testing with the first car, we came back and went through a bunch of flies, and there was just a few flies stuck right on the front of the car, like right on the front of the nose where the pressure point is, and they just blew over the whole rest of the vehicle. Same in the rain too; it just blows over the vehicle. It really is like driving an egg when you're in it. It's really quite a weird sensation, but it's quiet. It's dead quiet. It's like being in a glider. So it's a neat experience. And of course, the composite body, like we have a metal subframe and a metal rear subframe, but the whole monocoque is composite foam filled. So the resonant frequencies are almost nil. Like we have no harmonics going on in the vehicle because the material deadens so well naturally. So it's quiet. It's absolutely quiet. It's really cool. But yeah, crosswinds no problem. Rear winds no problem. Vehicles going past, trucks going past, no problem. A little bit of a sail, yeah, but compared to a regular vehicle, it's very minimal. It's only 2 or 3 square feet.
So somebody asked what the market is for this. So is this meant to be a primary vehicle or a vehicle where you have another vehicle in the family that is used for other purposes? Is it a practical community vehicle?
I see it as a vehicle for all the real tech nerds out there. That's what I see it. A vehicle for all the people who just love something crazy and love something unique and love something that's like different and an improvement, right? Like I got a friend with a Tesla Model S, and she said it's not only the best car she's ever owned, but it's the best object she's ever owned, right? Like that to me is like an incredible testament to the vehicle and kind of like what we're going for. So yeah, it was just for people who really get it and really get kind of, you know, want to make a statement kind of thing. Absolutely regular vehicle, you can use it every day, you can drive it wherever you want. So a lot of the interest we get in people who want to do long trips and then people as a commuter car. But a lot of people buying it because they want to do long trips and long voyages kind of thing. So that's and because of the efficiency we have as well, if you do plug it in a charging station, for 20 minutes, you get a much further range with our vehicle than 20 minutes in a regular EV2. So your charging times become much shorter as well.
Any tests on snow?
Not yet, but we've tested on cold weather lab, and we've done testing on pretty inclement weather, but not deep snow yet. No. But what we expect to happen is that the snow will get packed up inside the skirts. So I live in Calgary, so I mean, obviously you see snow quite a bit, and you see vehicles with snow packed into the wheels, and it just gets packed around the wheel arches and eventually falls out, kind of thing. Like, we're expecting the same kind of thing to happen. It's not a real concern.
Can you say anything about safety measures?
And we're like I said before, the vehicle itself is inherently ridiculously safe, and we're very proud. It's really one of the things that, like, personally, like, I got kids, like, we've all got kids. We all want everybody to be safe. And car accidents, they're unspeakably horrible. So we want to, and we're building cars. I mean, this is serious stuff. So, we want to make things as safe as absolutely possible. And we, from the tests we did years ago, like I say, we were breaking records in body strength. There wasn't any vehicle at 6 times vehicle's weight on the Aptera crash. Like I say, with the composites bouncing back to its original form, like, that to me sold me on the composite thing. Like, it was all good until that point, and then it was like, no, this is great. Like, now this is incredible. So the vehicle itself is very safe. We've got seatbelt airbags. We're basically designing everything on the vehicle to meet motor vehicle safety standards, like passenger vehicle safety standards. Like, that's our target kind of thing. And our real target is to supersede those. If you look at, like, a traditional car maker, a lot of the money spent in engineering is really spent to try and get down as close as possible to the safety margin. And if you talk to race car guys, they'll tell you that the vehicle safety standards are like really low, like really. Like, race cars are 1,000 times safer than a passenger vehicle. So there's a lot of margin there to play with as far as safety, and we're really trying to get up on the upper level of that and try and make this thing as absolutely safe as possible. The other thing too, because we've got wheel motors, we've got very interesting options on stability control and torque vectoring and all that kind of stuff. So when it comes to an emergency situation, we've got much better control of the vehicle itself than a regular vehicle. So just avoid getting into situations as well. Don't know much about the facial tracking. The autonomy thing is an interesting one. We're working with a few different suppliers on that. It's all getting to be way more simple than it was a few years back, like all this stuff is. So it's like the vehicle tracking stuff and the auto stuff, it's lots of options for what we can use it. As far as facial recognition, I don't know. But it is interesting, that one, actually, because so I'm assuming a lot of you guys are hobbyists and you've built electric vehicles and you know about controllers and you know about programming controllers and all that kind of stuff. And you guys have probably been keeping up on kind of where the control technology has been going. And you don't hear about this much in regular, because everyone has their own controllers. But for us, we've been looking at controllers and what's available. And controller technology, and this has been kind of kept a little quiet. No one's really been talking about it because I think it's just highly technical. But controller technology is I'd say doubling in capacity a year. We just finished building an e-bike project here. There was 8,000 settings in the controller. And you could tweak anything. And they're even saying that you can get rid of hydraulic brakes now using the controllers because they're so good. So these kind of like revolutionary breakthroughs that are happening through controller technology are really exciting. And the efficiencies are going up. And like I say, the people that get involved in controller design and software development are incredible. So again, we're really hoping to open this up to the people that are interested in stuff that own vehicles. You get different levels of access to the controller, but I mean, there's all sorts of fun you can have. So it's really exciting. And again, a bit different from other EV companies that don't give you any access at all to the controller settings. Like, we want to make that available if you have the inclination to play around with it, so that's really exciting, because that's going to be a lot of fun and people are going to be doing some fun things.
So when talking about control, do you all have any plans for doing anything towards autonomous driving, or just driving helps on long trips?
There's, like I say, there's if you go to an auto trade show now and you walk around the floor, there's 4 or 5 companies with booths that sell a complete auto drive kit, like plug and play. Like you put the camera here, you put the module here, and there you've got your control. So that whole side of driving technology is becoming really accessible and really quite easy. So we have power steering. We've got all the pieces on the vehicle to do the mechanical side of self-driving. It's just a matter of plugging in the whatever software pieces now. But like I say, it's becoming really easy now. Like compared to 5 years back when everyone's trying to figure out how to do it, it's you literally just go to a company now and just buy the system and plug it in. So so there will be some level of autonomy, but you know, again, we're not. You know, we see all the problems Tesla's having with that, right? And it's still very early days for that technology. You know, so we want to be careful there, right? We don't want to put people's lives at risk. So. That's fantastic. So how many folks out there, like, do you guys all like are electric car builders from way back, or like are you build conversions, or are you guys more just buying the, like, what does your club do?
I'm a Tesla Model 3 owner. Reserved mine right after the reveal, and I really do enjoy the autopilot, even though it's not complete. It sure makes driving cross country easier.
Mm-hmm. Yep. Yeah.
I was just going to say, I think someone was asking in the chat, and I'm also curious how you plug it in. Is it a standard J1772 and you don't have fast charging?
We are going to have options. So we've actually got enough room on the front of the vehicle where the charger's plan to go to fit 4 charging plugs. So we're sort of thinking, why not put one for all 4 of there? You know, I mean, it's just a matter of cost, really. But I mean, yeah. We're not a big fan of the 7072 plug, right? It's not great, but I mean, but again, because the vehicle's efficient, you plug it into a 110 and you actually get a significant charge overnight, right? So that's interesting too.
You have any price point information for the various models?
It's on the website. I think it's 20, started 26 for the base and goes up to 48, I think, for the 1,000 mark. It's sort of in that same kind of price range. We have an interesting kind of a business model too, again, because we, if you guys see what Tesla's been doing with their massive 800,000 ton, whatever, die casting machine, where they want to make all pieces of the body in like one piece kind of thing and minimize part count. We're doing the same thing through composites. So the main structure of the vehicle is like 7 pieces. I know the website says 4, but it's actually 7 pieces up on together to create the main monocoque. So it's actually a very cost-effective vehicle to build. And what we're trying to do is we want to try and help support and create more artisan labor in the workforce and in the factory environment. Right? So anybody who's done studies on workplace happiness and kind of how people feel, you know, good about their job is when they actually get to contribute creatively. And they get to, you know, do something that's meaningful and is, you know, has some kind of skill to it, right? So we're trying to create an environment where we can have a smaller team hand making these vehicles, kind of like Rolls-Royce does, right? But the vehicle itself is so simple, it allows the price point to be low. So we're kind of employing these high-end build techniques to a kind of mid-range vehicle, which is, I think, a new way of approaching vehicle design. Because vehicles are usually so expensive to make that corners have to be cut everywhere and labor has to be cut everywhere. I don't know if you guys know the famous story about the Ford Taurus and the chrome strip down the side. It was a 2-cent chrome strip, I think. It was a big story back in the 90s about how they didn't want to do it because it was too expensive per vehicle. And we're kind of taking a different approach, like because the vehicle is inherently simple, it gives us more margin to think about building it differently. And that's been a nice, refreshing, again, taking a different approach to design reveals opportunities, right, that wouldn't be available otherwise. So we feel that like eventually we'll have a nice, like it'll be a different factory than the car factories. It'll be more like a Rolls-Royce type, you know, handmade, people moving stuff and not having robots moving parts around because everything's lightweight. You know, people can move it. Like the whole body tub when it's made is only 190 pounds. So it's all human scale kind of components. And we want to create jobs, right? This is kind of what we're about. So, and good jobs, like jobs that people, you know, feel fulfilled and they feel, you know, happy about their jobs kind of thing. So.
And it sounded like you alluded to, this open, being able to work on it. Yeah, when I was a little disappointed with my Tesla when I tried to get at the CAN bus and everything was locked, and and then later everything was under certs, and so you really couldn't. Now they have some reason, over their updates, some things where you actually just have to secure it based, how are you going to do any over the air? Obviously you need security if you are open to networks, and yet, yeah, it definitely eliminated a lot of fun out of the thing.
Yeah, I would for sure, right? I mean, it's like I got a few home builds and they're great because you can tinker with them, and it's it's like when you put the chip in your regular car. Like I got one of the guys that works for me, you just put a chip in his car and you go to the app, you can tune your car from your phone, and in a new BMW, right? So, I don't see why we couldn't do the same thing. But yeah, no, but how deep we go, I think, is going to be up to the consumer, right? Because obviously there's various levels you can get to on controller programming, and you can really get to a point where you can mess things up, right? You switch off the wrong setting, all of a sudden you disable the whole thing and you don't know what you've done, right? So, but again, it'd be easy enough to have a reset, default reset. You mess with things and you just go back to factory default kind of thing. Like it's all very easy now. Like none of this stuff is complicated. Like an Arduino can run the whole thing. It's not, it's not complicated. Like none of this stuff is complicated now. Electric vehicle technology is I'm a big fan of radio control cars, and I've been racing the thing since I was a little kid. And the latest thing in RC cars is the controller is right on the back of the motor, like it's built into the can of the motor. So literally you have a motor and you plug your battery into it, and that's it. And that's your whole drivetrain. It's like, we're going to see the same thing with cars here. Like we're almost there with cars now. People don't realize how simple like they are, like electric vehicles. Like once you wire them up and the wire's happy and everything's happy, you never touch them again. Like they're fantastic. And, yeah, and there's so much fun you can have with them. Like you want more torque. Like what do you want to do? It's well, like why not let people have fun with their vehicles, right? It's like life's short. Like let's have fun with them. It's yeah.
The driving experience or the riding experience as you're sitting in the seats, it's designed obviously to be slipstream through, very air efficient, very aerodynamic. In terms of comfort, is it like sitting in a sports car in the sense that your legs are going to kind of be outstretched in front of you more, and that kind of thing?
It's a bit more sports carish in its seating position for sure. We've got the batteries on the floor, so we do have a fairly flat floor. So that's one compromise with electric vehicles you always end up with batteries on the floor is foot space and age point. So we always end up with more of a reclined kind of a position. But it's pretty similar to a Tesla Model 3 in its layout. Like we got basically the same brake, and there are standards out there, vehicle standards on passenger positions, and we follow all that stuff. So. From a passenger perspective, it feels like a regular car from the seating position. But what's neat is the cockpit. So because you're sitting in an egg, like the shape of the vehicle around you, you can see that it's interesting. And it kind of reminds me, remember Mork and Mindy at the beginning when he comes out in the egg-shaped spaceship? Like it's kind of like It feels like what that would feel like. You feel, and then other people freak out when you drive around, of course. Like that is one of the weird things about it. Like people have reaction to this thing, like I got a bunch of old cars, a bunch of weird cars, and people enjoy them. But this thing is people just don't know what to say. Like they just, it's an incredible reaction you get from people, and it's kind of like seeing the future, right? Like this is kind of what I think we're doing, is that we're really showing that the current state of vehicle design is going way off the rails, right? You go back, back to the turn of the century. There's guys like Edmund Rumpler back in Germany or Austria, I think, in like the 30s, doing studies on aerodynamic forms, right? And it was all ignored. Like there was a Tatra, I think, built one of his designs. And then like the first Saab, when the very, very first Saab came out, that was an incredibly designed vehicle. As aircraft designers did that one. And it's extremely efficient aerodynamic shape that eventually just kind of evolved into the 900, which lost a lot of the original aircraft kind of inspired design. And that's sort of been it, right? Like the first Honda Insight, like the very first generation Honda Insight, the aluminum one, from an aerodynamic standpoint, was like probably one of the best cars ever made. And then since then, everyone's kind of just completely missed the mark on what's possible. Like cars keep getting heavier and heavier. And really that comes down to If you inherit a vehicle from an engineering standpoint, so you're a vehicle engineer, you work for a company, and you get to do the facelift on the new F-150 or whatever, you can't, by the nature of the project, make it smaller. So everybody just adds to it. So that's why vehicles have grown and grown and grown over size, because every time an engineering team gets involved, they just add to it. So look at the RAV4 now to the RAV4 back in the 80s or 90s when it came out. The RAV4 now is the size of the 4Runner was back in the 90s. So vehicles are getting bigger, and that's the march that we're on, is this kind of like, and we just want to stop all that. Like, it's just crazy. Like 5,000-6,000 pound vehicles with one person. Enough people have said now it's crazy. Right? And everyone's saying it's the wrong way to go. So we're trying to just reset the whole thing and be like, look, like this is what's possible. And when people see it, they go, that's possible. You change people's minds, right? It's quite an interesting phenomenon. Yeah. Yes, so it is rather wide. It is rather wide, and that's a stability thing, also an aerodynamic thing. But it's not as wide as a sports car, like a Lamborghini kind of thing. So fine drive-throughs, we've tested it, drive-throughs, that kind of stuff, and it works. You got folks from all over the place here. You got somebody in San Francisco on the line. Vanessa Schmidt, yeah. Yeah, there's been so much, like I'm a big history buff. I love reading all this stuff, and it's there's been so many good stories through the years of amazing stuff that didn't make it to the mainstream. It's been, like there's a group here that are restoring a Mosquito, like a wooden airplane. Remarkable thing. Same thing, right? Great use of materials.
I noticed one of the items in the chat was about theft protection.
Theft protection.
Yeah, theft protection, like somebody's going to steal it.
Oh, it's the same as any other car, same as your Tesla.
The same as anything else.
Yeah, we got NFC to open the door, and then so it's all electronic, and so that's all normal kind of stuff on the safety side.
In other words, any unauthorized individual isn't going to get electrocuted if he gets in it.
You wouldn't do that, but it's dent resistant, so you're not going to get door dings, right? If somebody bumps in the parking lot, you're not going to get any impact damage. So that's nice.
Now, is the seating on that, is that side by side for two passenger, or is that inline?
No, it's side by side. It's a standard kind of two-seat layout.
Okay.
And it's the same kind of size inside as like a Honda Civic, like a first gen, second gen Honda Civic kind of thing. That's kind of what it feels like to me, like that kind of size vehicle. And in fact, the first Honda Civic, the one with like the hatchback, had a fantastic kind of cargo area behind the seats. We're kind of similar, and we're bigger there, but similar kind of layout to that vehicle as well.
And another question here is about, is this going to throw, as it was put, befuddle a car wash? This isn't something you want to take through a car wash, I bet.
I guess you could do it for the width was okay, but there's no reason you couldn't. Like, it's as durable as any of the vehicles. So, yeah. Battery warranty. That's an interesting one. Have you guys been following? So the trends in battery technology really are getting to now where the charge cycles are going way up. And there's a lot of talk now about batteries that are going to last, 3 times as long as the vehicle, right? So there's also talk about amortizing the cost of the battery over like 3 vehicles, and so like the vehicle wears out and you just move the battery to the next one kind of thing. And that seems to be coming along fairly quickly. So battery warranties are a hard one, right? But it's definitely getting to the point, especially with solid state batteries, where and the battery management systems are so good that, it's crazy where batteries are going, especially solid state batteries. I see Nissan's coming out with a solid state battery vehicle now, and that's mind blowing, because how you get a supercapacitor to hold a charge, I have no idea how they're doing it. It's incredible. But solid state batteries are incredible because they'll take millions of charge cycles, right? So
essentially, is this 2-door with storage behind the front seat?
Yep, it's got to be kind of a hatchback on the back, opens up. You can actually lie down and 2 people in the back. It's big enough to lie down.
Okay.
Yeah. So it's a pretty good size. Our life on the electric motors. We're not sure yet. This is brand new territory, this wheel motor stuff. We're working with a company in Slovenia called Elafe, who are the world leaders in wheel motor technology. And their stuff is incredible. And what's neat about the wheel motors that I realized, after talking to these guys, is that the motor itself isn't stressed. So all of the load from the wheel just goes through the hub, through the bearing like a regular vehicle, and the whole motor is just along for the ride. So any road impact, any impact of the wheel, curb impacts, that kind of stuff doesn't load the motor itself. So there's no like loading that can actually impact the motor, and it's protected inside the wheel. So it's quite remarkable, you know.
Is this a brushless DC motor, or is it a AC motor?
No, it's brushless DC.
Brushless DC?
Yeah. Cargo area at the back. Actually, the guys, so we're building a vehicle right now in San Diego, and the guys actually put a frunk in there. So they figured out how to repackage stuff around the front enough to get a little frunk. So apparently we do have a frunk now. Whether or not that makes it through to production, I don't know, because there is a lot of stuff. Being a three-wheel, you got to package a lot of mass up front as much as possible. Right? So you got to get your 75-25 weight distribution. The front's pretty tight, full of stuff, but apparently now we have a bit of room, so we might have a little frunk.
Now,
Just one of the cool things about this.
one of the earlier questions I saw was, would this be in a dealer network, or is this going to be direct from the factory type sale?
I don't know yet. I believe at this point it's all direct from factory. Like we're just going to be supplying customer orders for the first, we're like 1,000 orders now, right? So
yeah,
that'll just be fulfilling those orders until we get to that point, and then.
Do you have any idea about how many reservations you've gotten so far?
Yeah, we're about, well, last time we were over at 11,000 when I checked last week.
11,000?
Yeah.
Wow.
Yeah, so it's amazing, eh? Like that was really surprising.
Yeah. Well, I see from the participation tonight that we've got 50 people that have come on the site, and so there is definitely a lot of interest in this out there.
I know, it's fantastic, right? What kind of tire? Regular tires? They're just 16-inch rims. Nothing special about the tires.
Yeah.
We didn't want to make it so we had to get a special tire somewhere. We wanted to make it so you just get anywhere and get a tire for it.
Yep.
No, I love what you said about people being able to work on it. That's one of the big frustrations about every other car these days.
I know. And they're so simple to work on too. That's the thing, right? Like it's not like you open the hood of your gasoline car and try and do something. I mean, it's really all software, right? And then if do you have any mechanical challenges, it's going to be something very, simple to fix, right? So like the part count on our car is a quarter of regular car. So just inherently less parts to try and fix. So yeah, no, even like if you get into an accident, you want to replace like some damaged stuff, right? Like all the body panels, like because it's composite, you wouldn't, like people said you could repair it, but really it's like a motorcycle helmet. If you impact the major monocoque of the vehicle, you're just going to get a new one. And they're not expensive, and really the value of the vehicle is the battery first, and then the drivetrain, right, and then the interior stuff and the electronics. But the body itself is really not much value there. So to just transfer all that stuff into a new body would be a half day's job, and off you go. So that's kind of the philosophy behind all the repair stuff.
Yeah. Is it still? I imagine it's still private. It's not. Hasn't gone public yet.
No, it's all private. Yeah. All private, and again, the investment required that we need to get the vehicle to production is again orders of magnitude smaller than a regular vehicle, because we don't have all the massive stamping machines, like all the massive injection molding machines. We have none of that stuff. We're doing everything very simple and very, like I say, just we want to make it all in North America. We want to make it all in US and Canada, which means that we have to be smart about what we do, because we can't benefit from the cheap labor, right? So we have to just use processes that we have that we can use, and that's what we want to do. So example vehicle one, I believe it's 400-mile range. Yeah.
So you gave us the timeline for this version of your vehicle, with the three-wheel version. Do you have any idea when you're going to start developing and rolling out the four-wheel, four-passenger car?
It'll probably be about a year behind this one, right? So we've already got like a preliminary design. We're working on a plan that we want to try and use as many components of this vehicle as we can moving forward. I don't know if you guys saw the Top Gear episode about when they compared Porsche to TVR. If you remember TVR in England, a little boutique manufacturer, and the whole episode was about how TVR constantly innovated and cutting edge technology and always redesigning the cars and always coming up with new stuff. And Porsche just made the same thing for 25 years, right? They didn't change it. And which was most successful, right? And we're seeing a lot of this where, like, it's almost like our subconscious minds, we really like things that last and don't change, right? Like, we just feel comfortable when we know that we're going to get a part for that thing in 10 years from now. So what we're trying to do is create a family of parts that will be used through a family of vehicles that are all the same. So going forward, if you need to buy a wheel bearing or you need to buy a brake caliper, you're not having, like, it becomes a very simple process, right? And you can get a part from anywhere. We're trying to be as nice as we can to the person who owns the vehicle, right? Like, I'm going to own one of these things, right? I like working on my cars, and I like getting parts locally. I don't like having to wait 3 weeks to get a part through the mail, kind of thing. So, we're really trying to make it as accessible as possible.
So really just about a year's difference between the first car and then the next version.
I reckon so, yeah.
Yeah, that's pretty good.
Of doing the 2 and 3 mode versions. The range doesn't, a little bit, like, we're saving about 150 pounds on the back with the 2-wheel version. But the range is a little bit better, yeah. But I don't think we're going to see too many of the 2-wheel versions. I think most people are going to go for the 3-wheel version. It's quicker and it's not that much more expensive, and the safety improvement is quite a bit. Obviously, having control on the rear wheel is quite significant. So.
Yeah, when you're talking about that, obviously I've never driven a 3-wheel. What is that like? Can you kind of give us some experience? You know, what's different about it? How does it feel?
Yeah. Well, the principle of the 3-wheeler is the bar stool example, right? Like a 3-legged bar stool goes to 4-legged bar stool. If you distribute the weight evenly on the 3 legs, it's no less stable than a 4-legged bar stool, right? So if you get the weight distribution right on a 3-wheeler, it feels just like a regular vehicle when you drive it. Like, it doesn't feel weird. You hit potholes that you wouldn't hit normally, obviously, and we have to account for that with the tire design and whatnot. But yeah, it doesn't feel like anything different than a normal car, especially with the 2 wheels in the front. Because if you have the front window, it looks like a normal car, a little bit different, but you can see the wheels there and thing. But yeah, it feels like driving a Honda Accord sort of thing. It doesn't feel anything weird. And you saw in the video they would do the moose test, and it just goes around fine. It doesn't do anything weird. So. But the in-wheel motor is the weird one, because obviously, like, everybody knows, like, sprung weight versus unsprung weight, right? And reducing sprung weight has always been the maxim for car design, especially for race car stuff, right? You want the wheel to react as quickly as possible. So putting the motor in the wheel, now we're maximizing sprung weight. We've gone the other way from what an engineering textbook would say to do. But by putting the weight on the wheel, you get all sorts of weird things happen. First of all, you don't get any torque transferred into the vehicle itself. So all the torque is held, like, within the wheel, and it's all applied to the road contact patch. And all the weight is directly above the road contact patch as well in all cases. So you actually end up with a situation where you have more lateral grip than with a regular vehicle. Like, it's a very strange thing, and it feels different, because when the power happens, it doesn't happen on the vehicle, it just happens in the wheels. So it feels like it's happening out there. It's a really weird sensation. So I think that's going to be, for people, like, one of the really interesting sensations of the vehicle is what this in-wheel motor thing. And of course, like, we can do things like, if you imagine you're standing still in a parking lot and you creep this forwards a bit, and you creep this wheel backwards a bit, you're actually going to rotate the steering. You're going to steer the vehicle. So through torque vectoring, you can actually, like, simulate power steering. Like, we still have power steering in the vehicle, but there's a potential we could eliminate it and just do the power steering through the vectoring of the wheels. Like, like, that's like, wow, okay, this is great. This is really great stuff. Yeah.
Now in the front wheels, when you go around a corner, the front wheels, they don't tilt at all.
We've got some of the best suspension people on the planet working with us on this project, and the front is very much like a Formula car, right? Very nice long A-arms, inboard springs. It's a beautiful piece of work. Yeah, so it goes around corners just fine.
Are the wheels visible to other cars? So is there would there be a problem with people not seeing that the vehicle is actually wider because of the wheels and accidentally clip it by, like, going slightly into your lane or at a parking lot?
Yeah, I think so. There's a risk of that, for sure. Yeah. We do have lights all around the wheel skirt on the front, so at night they're visible, like a highly visible kind of thing. But yeah, no, that's yeah, through the nature of the design, having the wheels kind of stuck out in space like that, they're definitely going to get, you know, there's a potential for them to get hit. But the whole wheel skirt is designed to be replaceable. It's very cheap. So if you do hit something, and then of course the wheel and the whole suspension is designed to be as robust as a regular vehicle. So curb strikes, that kind of stuff is all designed to be just taken with the impact. But that whole skirt is for sure going to get cracked. It's for sure going to get damaged. But they'll be very cheap and easy to replace. So it's
How does this thing steer? Is it steered from the rear or is it steered from the front two wheels?
no, just front regular,
Just like regular car steering. Okay.
yeah, just regular car steering.
Okay.
Do have some, again, like if you look at race cars, they do clever things where they put the steering arm in line with the A arm, so you don't get the drag from the steering arm kind of thing. Like we're doing those kind of tricks. So there is a bit more thought into the suspension design, but it's one of my favorite parts of the car. Like when you see it just by the suspension on the wheels, it's beautiful. It's like, wow. It's a shame you can't just drive it like that and show all that off. But yeah, the steering is like a regular vehicle.
I'm looking at the spec sheet that you guys have online. What I don't see, what's the ground clearance on this vehicle?
It's 5.75 to 6 inches. It's basically 6 inches unladen, 5.75 laden, sort of thing. But it's kind of normal car clearance. Those are cameras in little pods. So we go for the cameras for the review. But because the shape of the body gets wider from where the mirrors are, we have to have the pods to get the cameras so you can see behind the car.
A couple of people were curious about whether it has windshield wipers and what the glass is made out of.
You were breaking up a second there. Sorry, was that about the glass or about the paint? Sorry.
Sorry. A couple of questions that people are asking. One is, does it have windshield wipers? And the second one is, what is the composition of the glass?
It does have a windshield wiper. It's a single arm, standard kind of stuff. It hides under the cowl when it's not in use, so you don't get drag from it. And the glass is standard. It's a laminated windshield, and it's tempered glass like a regular car stuff. There is, because we are an autocycle, we do have the option of doing polycarbonate windows, which isn't an option a regular car maker would have, and it does save us a bit of weight, but it's not as durable as glass, obviously. So, but it is an option for us, and we are exploring that. So.
The images I saw online, it looked to me like instead of side view mirrors and rear view mirrors, you use cameras. At least that's what I was seeing. My question is concerning, again, I'm going back to snow. I picture myself arriving on a snowy evening somewhere up in the mountains. And what happens on my Tesla is the rear view camera always gets covered with snow and whatever muck is out there. And I can't use that camera when I'm backing into the garage. I don't know where your cameras are placed or if that's what I was seeing, but if you could just comment on that.
No, for sure. We've got 2 cameras, rear view cameras on the door, and then we've got a camera right on the back. But the reason your camera gets dirty is because on a regular vehicle, as the air exits the back of the vehicle, it creates an eddy, right? That spills off the back of the vehicle. And that eddy comes down and transfers all that muck onto the camera, right? So especially station wagons, I got a couple of Volvo station wagons. It's the same thing after a journey. The back window is just dirty because of the eddy created from the drag from the back of the vehicle. Whereas on the Aptera, we come right down to basically just enough for the room for a motorcycle plate. And then we, next to the plate on the tallest areas where we vent out the cabin air. So the cabin air actually fills in. We've got one little pocket of air with one little turbulence, and then the cabin air comes in and fills that in. So the slipstream of the vehicle, basically, it just touches like an aircraft wing. It just touches behind the vehicle and then just disappears. So
Wow.
you shouldn't have issues with the rear camera getting dirty. There's no turbulence behind the vehicle.
Hey, I was wondering, when when you go to start production, are you going to go in reservation order or according to options? Go with all-wheel drive first or biggest battery first, or?
Oh, I believe this. I believe the celebrities go first. I'm just kidding. No, we just go order, just order received. We're just gonna go as fast as we can to get them out. So, yeah. There's a back wheel bounce up and down to allow rear rotation, and front wheels turning in opposite directions. The rear wheel is just a regular swing arm. We looked at doing fancy things on the rear, but really the weight penalty wasn't worth it for us. Licensing problem because it's motorcycle? No, actually, Nebraska is the only state right now that has an issue with this, and they're changing their laws right now. So every other state is no problem registering as a motorcycle. And yes, there's no paint; it's just wrap.
Well, I mean, you're in Canada, so how about Quebec and Ontario and all that? Just curious.
Canada, man, I'll tell you, they're so far behind. Federally, it's legal. Federally, it's legal anywhere in the country. Provincially is where they make up their own rules and we might have some issues. But yeah, that's Canada for you. But yeah, I saw a Harley Davidson trike on the road here the other day. So if a Harley Davidson trike is allowed to drive on the road, you know what I mean? Anyway, just saying. He plans to make it autonomous self-driving. Not at this point, but like I was saying earlier, that whole technology suite is becoming much more accessible now and much easier, right? So 5 years from now, it's just going to be a plug and play kind of thing. So, yeah.
I think you must have already said this earlier on. I joined you about 10 minutes late, so I apologize to the group if this is repetitive. When are the cars going to be up for sale?
Limited numbers beginning next year and then full production by June.
What does limited number mean, do you think?
Well, less than 10 in January, less than 50 in February, less than 100 in March, kind of thing, but those kind of numbers. And it's actually Monroe working with us on all that. So Sandy Monroe and his group are doing all the production planning for us and all the plant layout and everything. And they're incredible. Like these guys are absolutely incredible. And we've got kind of like I don't know if they call it a hybrid factory or what they're calling it, but the plant layout that they've done for us is not like any of the plant layout that we've seen. And it's a lot of human labor because the parts are light. Like we said, it's human focused, which is really interesting. But yeah, it's all coming together. The production plans, the factory layouts, how it's all done, all the dunnage, all the cranes, everything like that is all coming together. And yeah, so there's a lot to do between now and then. But yeah, we hope to be getting the first cars out January. And Jay Leno might be first. I see that one there. I don't know if he's going to get the first one, but I know we are working on another piece with him, like right now. So he's probably going to be involved at some point. And the off-road kit, there's a question here about that. So yeah, so the off-road kit, yeah, so it'll be different wheel pants. If you are going off-road, you can just take the wheel pants off as well. They're only required as an on-road vehicle. And then we are looking at a height adjustable suspension. So if we can do it without a huge weight penalty, we'll do that. Because that gives us a lower ride height of speed as well. So that would give us another level of improvement. Batteries in the wheels, that's scary. Actually, the last one I saw recently was a massless battery that used the carbon fiber weave as the battery. I don't know if you guys saw the article, but they had basically like the weave of the carbon fiber, and one side was the cathode, one side was the anode, with the separator between them, and the whole shell became the battery essentially. And they were only 20% as efficient as a lithium battery now. But that means we could literally turn a whole car shell into a battery. Like that's really, really weird stuff. But probably not batteries in the wheels. So, other questions we got? Yeah, the security one's good, right? With the phone-based keys instead of the key fob. Again, we've got lots of options there. Nice. There's some great questions in there. This is a really good group, eh?
Well, ask them.
I'm just looking through the list here. What do we got? I think I've answered most of these. Seal replacement on the motors every 30,000 miles. Is that something, I haven't saw that one. Is that something Alafli's talking about? Seal replacements every 30,000 miles? That would be something we'd probably move away from because we can change that with different seal technology.
When will there be an opportunity to test drive?
I don't know. If you actually go down to San Diego now, I don't know, on the YouTube channel, there's a girl showed up there with like a little, like she's from England. She had like a little YouTube channel, and she showed up and said, "Hey, can I take a ride?" And they took her for a ride, and she posted it, and it's fantastic. And it shows the acceleration actually, which is really good. So I think if you go down to San Diego, just gonna knock on the door, you probably get to have a ride. They're pretty friendly down there, so. But it's crazy. If you go on the YouTube channel and check out that video, actually, you can see the acceleration. It's really remarkable. Like, those motors are going to be incredible. How flammable is the shell's composite material? It's not. We actually have flammability inhibitors in the composite resin itself, so it doesn't burn.
No, that is good to hear, because I mean, Ashburn, Virginia, we just saw a bolt catch on fire.
Yeah, I saw that one. The guy in one of the guy's garage, right? Yeah.
Yeah, right there. Ashburn is about 5 miles from me, so oof.
Yeah, that's scary. That's scary. Yeah, no, we've had a few.
They're doing a recall on the bolt right now for that, and I don't think they're finding too many batteries that need module replacements, at least from my experience with our bolt, what the guys at the shop said. But I don't know. Some of these guys seem a bit comical, so I don't know how much we can trust their diagnostic work.
Is that what it was? It was just a cell shorted out and go viral.
Yeah, apparently they had a batch out of Korea, that the batteries that were problematic, and so they recalled all the bolts that might have those, doing some kind of testing procedure and changing the software so that later on, if a problem develops, it'll let you know sooner rather than later. We notice the software change now whenever we get out of the car and anything's in the back seat. It tells us to check the back seat. So even though the guy at the service center said, no, we didn't change the software because you didn't need it, we know they did, which was actually part of the 11-page NHTSA brief on it.
Yeah, and apparently they didn't have the software update, the ones that had the fire.
We've been looking at some interesting forums in, guys doing home built batteries and that kind of stuff. And there's a bunch of people experimenting with a way to cut the nickel plates. When you connect the cells together, you actually do like a little spiral where you connect the battery, and it becomes a little fuse. And if the battery ever happens, like anything happens, it just burns that little, it removes itself from the pack kind of thing. I think it's really clever. And we're experimenting with that, see if it works. Like it's, but that's a cool idea. I like that kind of stuff. When will you add wings? I know, right? I know. I keep telling the guys, we've got the perfect like platform here for a flying car. It's aerodynamic, it's lightweight, you know? No, I don't think it's in the scope at the minute.
Range.
Will you build your own battery packs, or are they from a third party? We are building our own packs. We're using standard cells. But this is a crazy one. Like if you had $1 million to invest in a battery company, right? Like right now, like where would you put your money? Right? Like it's changing so quickly, and every 6 months there's a new technology. It doesn't quite make it to market, but it threatens to kind of like change the whole industry again. So battery technology is a really weird one, right? Like we have these lithium cells today, they're pretty good. 5 years from now, they're going to be way better, different chemistry. 10 years now, something different again. So we're trying to be kind of battery agnostic to a degree, and also the idea that you can upgrade your car or change the battery at any point to a different battery chemistry. It's just a controller, thing, so it's not a big deal. But yeah, the batteries are almost like we try and keep them like separate from the conversation, right? I don't know if you guys saw in China now, there's a company that sells the battery separately from the vehicle. So that's something we've been talking about doing for years and never actually did. But from that perspective, you got a $40,000 car, $20,000 that is the battery, right? So if you remove that from the sale price, maybe you buy the car, lease the battery kind of thing, you change the whole economics of the vehicle ownership. So there's a company in China doing that now. And as I said before, with batteries, it looks like they're going to start lasting way longer than the vehicles, which means you can amortize the cost of the battery over 3 vehicle lifetimes, right? So like where it's going to land on batteries right now, like no one has any idea. right? It's really a strange time to be in this industry, right? And of course, with the mineral resource issues and mining, all these mining stories coming out about lithium extraction and all the horrible stuff you see around that kind of stuff now, like we're going to start seeing more attention put, I think, to battery technology. And like, I think we're going to see some interesting alternatives coming out here pretty quickly, right? Especially on the solid state side of things. I think we're going to see some interesting breakthroughs.
Speaking of the solar panels, I assume that's thin film solar. I just was curious what type of cells and what the total wattage is.
Total wattage, I'm not sure. They're regular cells, like regular silicon cells. We found the highest efficiency ones we could, and that's what we're using. But they're just a monocrystalline cell, like you find in a solar cell. They do bend a little bit, which works in our favor. That's how we're able to do this. 700 watts. Oh yeah, that Japanese motorcycle manufacturers thing is interesting with the batteries. It's an interesting one though. You know, I don't know about that one. It's weird, right? Because so in our vehicle, you take out 4 bolts and the belly pan comes off, and then the battery's right there. You got a bunch of bolts around the battery and it comes out, right? About 24%, yeah. So the battery is something that we could, and of course, as for the big battery, like if you just wanted a 200-mile range, your battery is literally like suitcase size, right? So, you know, that's something that you could get out fairly easy. So I don't know. Obviously, it wouldn't work for a vehicle. Actually, what I have seen in India, have you guys seen how they standardize on the same thing, but like in the tuk-tuks? There's little kind of like, you know, little cargo vehicles have done the same thing, but they've kind of done it, they sort of did it accidentally, where somebody came up with a standard. Now it's kind of become this widespread thing. And it's similar to the thing they're doing in Japan, but bigger batteries. So like they're almost too big for one person to lift up. And of course, that's the issue you run into, is just being able to handle the batteries, because they get heavy real quick. But it's cool, that standard, eh? I like that one. The interesting one about that one too is that when you put have you seen the rack that the battery goes into? I think there's a company in Europe doing this, where they have like on the street, they have like a big rack of batteries. You just go plug your battery in, take a new one out, put it in your vehicle, and off you go. That rack now becomes the center node of a microgrid. So that thing holding all those batteries becomes something that can actually power the local community. So it's a very interesting idea with swappable batteries, because you get to the point where you could kind of replace the grid with enough solar vehicles, right? So the resolution of the video camera, it's just normal. I don't think it's anything too crazy.
I'm curious about climate control, audio, and other accessories, and how those affect the range.
Yeah, no, it's an interesting one, that. So finding lightweight speakers, right, that kind of stuff has been a real challenge. But we, same on the HVAC too. And the HVAC is obviously a massive part of the power draw on an electric vehicle, right? And also from a weight perspective and a cost perspective. So we're coming into this at the right time now. 10 years ago, you try and find a HVAC unit for an electric vehicle, and they did not exist. If you go out to the market now and you want an HVAC for an electric vehicle, there's about 20 options. And they're all really good. And there are some made in Canada, some made in Europe, and some made in different places like that. So the cost is accessible now for like a regular kind of HVAC. So we just got like a standard HVAC system. We don't have a heat pump yet. We would like to do that, but we're kind of like Tesla in that respect, where it's one of those engineering challenges that's just kind of like too much from the first phase. So regular HVAC for the first car. Steve is a ridiculous audiophile. He's made his own speakers and all that kind of stuff. So we've got this insane 11 speaker system in the thing with subwoofers under the dashboard and speakers everywhere. Like it's incredible. But we're working with the company on lightweight speakers and getting the weight of the speakers out. Even the coils and everything, they're trying to make them lighter for us. Heated seat or steering wheel. We've got prototypes where we've got heated and cooled seats. And that was something that we tried to do to get the efficiency down on the air conditioning. And there's been a whole bunch of studies on blowing air directly on your body, like from the back and the back of your neck, that cools the body more effectively than air blowing on you. So we've tried the cooled seats. They seem to be okay. It's kind of a weird feeling. I think kind of like your bum get real cold, but way less power than blowing cold air out the vents kind of thing. So we are looking at that, yeah. Yeah, so to close the doors, you reach up and there's a strap. You just kind of reach up like this and pull it down. The door only weighs 40 pounds, so it's a very lightweight door. And
Whoa.
so and then opening up in a tight space as well. The door doesn't open any wider than the wheel skirt, so you're never going to get in a situation where you can't open your door. And it doesn't open much higher. It's like the Model Y with the Model Y model, which is the Tesla with the crazy back door. That one is similar with that one, where it doesn't actually create much vertical room above the vehicle.
That's the Model X.
X, yeah, with the Falcon doors. That's right. Those marvelous pieces of engineering. Did you already tell the charging ports and rate of? Yeah, so the charging ports, we're in a position now where we're actually moving the charging port from the back of the car to the front of the car. So before we had it under the license plate, which we were pretty sure was illegal. I'm pretty sure it's illegal to hide your license plate at any point. So we kind of abandoned that, and we went, and again, to move some of the components up front, the charger and stuff. The port is going to be on the panel that's where the logo is, and that panel is actually big enough to house 4 different charging plugs. So we don't know if we're going to do that yet, but we could. Pricing is in the 28, 29 to begin, and then up to like 48 for the big one, for the high-end one. The rate of charge, I don't know the numbers exactly yet because we're still working with vendors on different charges. Like I said before, what you get per mile on a 20-minute charge is going to be 4 to 6 times for us what you get in a regular EV for the same amount of time, just because the efficiency of the power transferred. Like you transfer the same amount of power, but we use much less of it, right? So you get more range from the time that you're charging.
So I got another question on the charger. I mean, are you thinking of licensing the Tesla charger?
I don't know. Those guys, Elon said like a while back that he's not interested in 3-wheelers, right? Like he doesn't think they're a viable thing. So I think he wrote us off before we even had a chance to talk to him. But as far as I know, there hasn't been any, and that's locked down pretty tight, right? Like you can't just go ahead and use it. So we have to, but who knows, who knows? It's our favorite plug. It's our favorite type of charger. That's great. How does it handle in heavy winds? I mentioned this before, but it actually doesn't, it's aerodynamic in every direction. So it actually doesn't have any effect on crosswinds. Like if a semi-truck goes past you, you don't feel it. Like you just don't feel anything. Yeah. And with the weight on the tires too, again, with these wheel motors, you get an interesting thing where you don't, like the loads on the vehicle aren't being taken through the suspension, like the weight is on the wheel. So when there's any load applied to the vehicle, you got a much more direct kind of contact patch than on a regular vehicle, or you're not going through the suspension to the contact patch, like you've got weight on the contact patch. So it handles differently than a regular vehicle. ABS, yep, ABS, absolutely. And in fact, through the software, we've got like the craziest ABS. Like we've got all sorts of torque vectoring and all sorts of whatever you want to do. And on ice, it should be great. Like, of course, any car is going to be slippy on ice, right? But as far as like a vehicle control standpoint, like what we can actually do with the vehicle, like we can place it exactly where we want it, because we don't actually we've not only got like rotational control, we've got positional control on the motors. So we can turn it, right? Like we've got resolution, we've got 1,000 degrees resolution per revolution. So we can just literally place the vehicle wherever we want. He plans for a charging network like Tesla has built. It'd be nice, eh? That's big money stuff though. So I think we're just looking to plug into the regular networks at this point. Can you drift the Aptera? Yeah. Like I say, with the motors, we've got drift mode, we've got whatever you want to do. I mean, the Lamborghinis, how they put you at a 20 degrees in the corner and go, oh, you got a 20-degree drift with the corner through the electronics. Like we can do all that kind of stuff too. I used to look into at paper and even with UV with the HVAC. HEPA as far as like a cabin filter, you mean? Like kind of like the Tesla has from the. Yeah, that's a great idea. Hey, I love that one. Yeah, I hope we can do that one. And even UV, all like putting UV. Oh, that's an interesting idea. Is anybody doing that now? Are you using UV in the HVAC system? I haven't heard anybody doing that. It's a cool idea though. 0 to 60 is sub 3 seconds at this point. So it's quick. Yeah, no,
Nathan, I wanted to throw in that some people have been doing UV in buildings where they have it up above everybody because you don't want it shining on anyone's skin. But in the early days of COVID, they were talking about using it to make buildings safer to be inside.
And they use it in water treatment, right? I know they do it with water treatment plants. braking efficiency. That's an interesting one because we, so to qualify as like a vehicle and to pass all the standards and stuff, you have to have, so the laws haven't caught up yet with where regenerative braking is going and what it can do. So the laws still require you to have your dumb brakes be able to stop the vehicle in a certain amount of time. So by law, we have to have more brakes than we need, which is really annoying because there's more weight than we need. But we're basically using the regen for most braking. Like I said before, the regen is you don't get full regen in a passenger vehicle because it gets scary aggressive, right? Like you can lock the wheels up kind of thing. So we're using regen as much as we can. And because we got lean wheel motors and we got such control of the wheels, we can get much higher fidelity in the ABS system and on the regen system. So we can capture more energy, but we can use less brakes, right? I mean, that's one of the beautiful things about electric vehicles is you don't wear the brake pads out, right? So what speed will your cherry be most efficient? The faster you go, the more efficient it is. What we haven't done yet is a top speed run. Actually, that would be something to do, to see how she feels at like 200 miles an hour kind of thing. It should be absolutely stable. With all sunny days, how long would it take to go coast to coast after solar? You only get about 45, 50 miles a day on the solar panel. So divide the distance of the country by 50 days, and that's how many days it would take you. 0 to 60 under 2 seconds, yep. Nice. And does the Bolt have the pedal where you let off and you get the regen and you get the gas too? I know some cars are using that technology now.
Yeah, if you put the Bolt in the L, there's pretty aggressive regen when you take your foot off the pedal. It's kind of like driving a stick manual car. And then also it's got a paddle on the wheel. So if you want a little bit more aggressive for panic stops, you can use that. Like I say, the only time I use the brake pedal is when I'm at a stop. So if someone rear ends me, I don't jump out into the intersection.
Yeah. No, that's nice. That's nice. Yeah. So like we built, when I worked on a car called the Volvo 3cc back in the early 2000s. That was kind of an interesting vehicle, but on that one we had the gas pedal that was 75% gas and then 25% regen, but it was proportional, right? So you could actually like slow the car down proportionally, and it was a delight to drive. So I know a few cars are doing that now, where it's actually proportional. If you let your foot off, it's not just like regen comes on. You can actually like dial it, right? So you can actually like brake your car controllably using the gas pedal, which is a really, really nice way to drive.
Yeah, absolutely. That's the way the Bolt is. You can have the pedal wherever in low, and it does exactly what you want it to do.
And it feels like how it should be, right? I mean, you got control with one pedal. Anything to discuss on the microcooling type? The microcooling stuff is aircraft technology. It's straight out of the aircraft industry. It's just a radiator behind the skin and then a micro abrasion, like a film on the skin, just to increase the surface area, and then a bit of thermal paste, and you get skin cooling. It's expensive. That's the only thing, right? Like it's quite a complex little system with channels in the composite. So it's much more expensive than a regular radiator, right? But if we open up any kind of radiator opening, we'd double the drag of the vehicle, right? With like even a little thing under the vehicle to let some air in, we'd essentially be doubling the drag. So we took the price hit and we kept the aerodynamics, and we're doing the skin cooling. But yeah, no, it's all standard aircraft kind of stuff. I think so. Again, the question about Jim about the pedal driving creep, like I think that'd be something that we should be able to open up. Like that'd be one of the things I think we should be able to give people the capacity to tune, right, and how they want to drive the vehicle. And again, because we're not a car, we have some liberties here, right? Like we're trying to make it as safe as car, obviously we're trying to meet auto standards, but it does give us more freedom of what we can do on the technology side, right? So we're not as restricted as a regular car. So we might be able to do some more interesting stuff on the regen side. No heat pump to cool the battery. There is, yeah, we do have a heating for the battery, but we're actually finding with the motors too, we're not actually generating enough heat to really warrant like the cooling being really used too much. Like we're only generating 10% of what the cooling system can do on the motors, and we don't seem to be getting any hotter than that. So, and the batteries are staying really nice and cool as well. Like nothing's really working too hard. So, we're not moving 5,000 or 6,000 pounds down the road here. So everything's kind of has a breezy time of getting those electrons around. But yeah, no, the heat doesn't seem to be an issue. We've tested in hot climates. Oh yeah. In fact, the very first car that we built, we took out to Death Valley. and tested in high temperatures. You got to be careful with the composites, obviously, like we're, with composite material, it's you get into a really hot day and you got a black car, you're going to be getting close to the glass transition temperature, right? So we do have high temperature resins, and we got different things in the resins we do to keep that safe, but it's that's definitely something that we concern for composite vehicles. That's why you don't see black composite aircraft. They're all white, right? Because you watch the heat. I need to warm the batteries in cold. Probably, yeah, we'll probably need some temperature control of the batteries. So we got a liquid cooling, liquid heating in the batteries, like a standard stuff. Nice, a white one, nice. Yeah. And there's a question earlier too about paints and paint films. And I think I mentioned that we're only doing paint films. So easy enough to change your colors or modify your vehicle. Will it float? Yes, it will. Yeah, absolutely will. Even with the doors open, it'll still float. Like the structure itself is inherently boat-like and would float, yeah. In fact, with that smooth belly, if you enter the water fast enough, you'd probably skip along for a while before you stopped as well. In fact, you probably would actually drive in the water. Anyway, so I know that's the thing. Electric motors don't care. You can fill an electric motor with water; it doesn't care. It's only if you get into the electronics that it really cares. That's a nice one. Actually, what I was messing around the other week with on the back of the car, we've got the skirt, we've got a little piece on the back that's a bumper. So if you get an impact, it's just a little foam piece. And I was playing around with the idea of making that like an active trim tab kind of thing, like an airplane. But I was shut down on that one. USS Aptera. Nice. Nice. This is a fun group. How am I doing for time? Like, how much longer are we supposed to go on for here?
Well, we, as long as you can hold up and they keep asking questions, we can, go longer, or if you have some time restraints, why we can.
Well, let's do another 15 minutes.
Accommodate that too.
I do have to get back to work here. We've got the car to design. Changing a flat tire. The flat tire is a fun one. The car doesn't weigh much. I mean, like 2 guys can lift up the back of the car. So we've got standard kind of jacking points and very simple like quarter turn fasteners to get the panels off. So quarter turns, panels come off, jack goes underneath, and then you just put the panels back on with the quarter turns. So it should be fairly straightforward. Yeah, no spare. No, we don't even have a run flat actually, and actually that's something we should probably think about. Because yeah. Thank you for that. We'll bring that up at the meeting tomorrow. Spare tire. Yeah. I think that's the thing, is the compressor and the goo. But
I like the question.
In-wheel motors, but no flat changing issues. No, that's the crazy thing about them. Basically, if the wheel motor is almost like a drum brake on an old vehicle, right? It's exactly kind of what it's like actually. So when you take the wheel off, there's the motor, and you take the wheel off, it's like a regular wheel. And it's even a regular wheel, like the hub bearing is a standard hub bearing. It's not anything weird. It's just a regular bearing. Financing. I don't know. Actually, I don't know about that one. I know that the whole world of financing is getting more creative at this point. And I know that there are financing companies that have approached me about helping with financing. So it's not my department, but I know that's a towing option. Or like to tow something with the vehicle? No. No towing option.
Size of your wheel, size of the tires.
It's still kind of in flux, but it's a 17-inch rim. I think it's 5 inches wide. Standard kind of profile. It's a standard Michelin. I give Michelin and Goodyear. Standard kind of tires. We looked at doing like a BMW i3 tire or like that kind of crazy stuff, and it just became unobtainium to get them. And you want to change your tire somewhere, you just end up having to be stuck for 2 weeks waiting for something to show up. So we ixnayed all that, and we just went with the standard tire. It's a low rolling resistance tire kind of thing, but it's a normal.
Well, Michelin's coming out with an EV tire in a month or so that's supposed to give even more efficiency.
Nice. Yeah, everyone's working on it. It's great. Did you guys see that Mercedes that just came out too, that they're claiming an incredible aerodynamic efficiency on? I just saw it the other day. It's a beautiful car. But they're really trying to hit the aerodynamic kind of button now. Seems they can make some progress there, which is good to see as well. No loss of cargo space. All the batteries are under the floor all the time. With the, yeah. From a weight perspective, we have to keep the batteries down and forwards. So, but this kind of thing too, like I said, this seems like an outrageous number now, but if you look at battery technology, like 5 years from now, this is going to be, it'll be irrelevant. It'll be, this will be normal. It's really changing quickly. Minimize the CFD, exactly. Well, it's actually really interesting. The CD side of things is fascinating. That's we've had some amazing people through the years help us on the CFD calculations, and the team we've got now are just remarkable. But when you normally throw something in a computer, like a CFD program, you see all these issues and you see all this big mess and turbulences and all these different things, eddies coming off. And when you throw the Aptera in there, you see like a picture of an airfoil going through like a CFD, like it separates and then it reattaches at the back. So the results you get are just beautiful. Like they're having so much fun, and the aerodynamicist guys are like, finally, something that's aerodynamic that we get to work with, instead of something that's non-aerodynamic that we're trying to fix. So the simulations we get are just like they're beautiful. And that software now, the simulation software, is becoming to the point where, if you guys know about generative design, which is a type of software where you just put a basic volume in with loads, and the computer calculates the structure of the part for you. Right, so it calculates the strongest part possible with the minimum amount of material, and a computer can do orders of magnitude more than a human can do as far as efficiency and iterations to a design and coming up with like the most efficient design. So the generative design software is now being applied to computer dynamics. So you can actually create like a boundary layer and then have the computer define which is the most aerodynamic path through that boundary layer and then give you that result. So like the software side of things now is just absolutely mind-blowing what we can achieve. It's quite crazy. Can pick up in San Diego rather than delivery. Nice. I think Sarah, who's our main like marketing lady, she's up for any and all ideas about delivery and having fun with that, and how we get people their cars and going to the factory and stuff. I mean, it's I think basically whatever you want to do in that side of things. I mean, even visiting the factory, like I have friends in the past that bought a BMW and they went to Germany and saw the car being built and then drove it back, kind of thing. I thought, what a beautiful thing to do. Like that's a nice thing to do. So it'd be nice to get into that kind of thing. Factory tours, yeah, I don't see why not. I mean, like it's a non-hazardous work environment, right? So we don't have to worry too much about welding and paint and all that kind of stuff. So it should be fairly accessible to everybody. Do you guys have any other ideas? Like I always like enjoying using these kind of things to try and get some good feedback. So as we kind of wrap this up, is there any crazy ideas anyone's had, or any interesting kind of thoughts kind of thing that we can maybe take back to the team with?
No, I'll just say this. You already did one of my ideas, in-wheel motors.
That's a good one. We'll take that one. Thank you.
Well, Nathan, how about having the rear tire exude a biodegradable lubricant so you can spin on a dime?
Did you see that? There was actually a GM car back in the 50s, I think, for snow. You had a little thing in the wheel arch. You could spray some kind of lubricant on the tire so you get better traction in the ice. It was like a real thing, like back in the 50s. I think it was a Chrysler thing. So we probably don't want to like decrease the friction. We want to increase the friction. But.
Well, it's only for parking when you want to spin on a dime. One front wheel runs forward, one runs backwards.
We can actually crab the vehicle like a bobcat with that much power standing still. We can literally just tank it. Like we can just crank the one side and it'll just tank around.
So the rear wheel just slides sideways.
Slides, yeah. Oh yeah. The front wheels just pull it like no problem. Yeah. So you could do all sorts of things with that one, yeah. Four-wheel vehicle, yes, we are considering a four-wheel vehicle. And then I've heard talk about like a truck and all sorts of other things after that. So you know, the kind of overall concept here is that, you know, everyone's missing the boat on lightweighting and aerodynamics. You know, everyone's kind of just completely miss the opportunity there. So we see opportunities to do all sorts of vehicles using those same philosophies and getting the same gains in efficiency, right? I mean, why not?
Well, a lot of Americans are terrified of the idea of being in a lightweight vehicle because when it gets stuck between a couple of trucks, they can't imagine it being kicked out of the way like a soccer ball.
Yeah. Well, that's what we're trying to fix with this whole notion that a lightweight vehicle means it's less safe than a regular vehicle, right? Like, which isn't the case. It just depends on the materials you use. Like, if you made a vehicle out of cobalt, right, it'd be tremendously strong. You know what I mean? So it's like, you just pick your material, right? And and actually when we did the first car, we actually designed the front subframe to shear on an impact. So we had it at 45 degrees so that the vehicle would go up and then the main mass of the vehicle would stay, and you'd actually separate and go flying up and remove yourself from the accident scene, right? Just get yourself the hell out of there and off you go skipping down the road in your little toboggan afterwards, right? But we scrapped that idea. It wasn't gonna work. But no, it would like when we actually get to the point where we're like destroying vehicles again, like, and we can release those videos, like people are going to be amazed, like how well it performs. You know, it's like you throw it off a building and it would just bounce. You throw a 10-story building, it would just go boing, 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 and that'll be it, right? A great tailgating vehicle, no, because you wouldn't get any pull from the vehicle in front of you. You would barely get anything. The cargo space is actually an interesting one because we're working on a design now where we have a bit of space behind the passenger compartment where we actually can have like a lower storage, like panels in the floor that open up, because we've got some space down there. We wouldn't want to add anything heavy there. Tailgating at a football game, yes. Actually would. That should be fantastic for them. But if we had a smaller battery, we actually have more space under the floor now, so maybe that could be used for cargo, that kind of stuff. Like personally for me, like I don't drive very far. Like a little battery, like a quarter the size of the big battery would do me, right? Which is basically, it's only like a battery about 2 feet long in the width of the vehicle. And you'd have all sorts of space under the vehicle if you did that. 3-passenger version. Like the McLaren F1, I wish. No, I don't think so. No, it's not, the body's not that wide. Although that is my favorite car of all time. So if I could have a 3-passenger, I would. A lake sailing option package. Nice. We're gonna have to take one in the bloody water now. Oh my goodness, that's crazy. Did you guys see, I don't know if you know this, but the first Aptera, if you guys any Star Wars and Star Trek buffs out there, the Star Trek movie that came out, the first one of the new series, the Aptera was actually in that movie. In the university scene where they go back to school, and in the background, the car drives by in the background. They approached us to put it in the film the first time, so that was one of our cool moments on the first round. Yeah, that one, yeah, the Star Trek, yeah. We got some great pictures too. We got pictures from when we took it to the White House the first time. We actually campaigned, and I believe we won. I think a few of the companies won to try and increase the weight of a motorcycle, so that we could be classified as a motorcycle. And we took it to the White House before, and there's some great pictures there too. Possible backpack for everybody. I think the backpack storage is still there, yeah. There's some other ideas now. Jason Hill, who's our kind of like main designer guy, who's incredible. He's got all sorts of fun ideas for the interior, especially like on the camping side of things. And like, anyway, there's gonna be lots of fun stuff. And it's going for like a real like wetsuit fabric style interior that's like wash downable and really durable and stuff. I don't know if the credit got approved yet. I think that's something else that we're actually working on as well. Yeah. All right, so we got the lake sailing option package out of this. We got the spare time. What do you guys, the question to you guys too, how do you feel about vehicle to grid technologies? Like do you guys feel there's any like relevance in North America for V2G or any use for it kind of thing? Oh, Jeffrey, you're on mute, man. I think you had a good point there.
No, I'm just saying, bring it. Well, I'm trying to use hand gestures, but I'm saying, bring it, man. Get the VTG. We want that stuff.
Yeah, here in California, Here in California, we have all these PG&E power shutoffs to avoid fires, which we get anyways. And vehicle to grid would be very handy to get people through sometimes 3-4 day power outages.
Which you would be able to get, right? You'd get 2-3 days easy with the battery pack and this kind of thing. No, I know, right? It seems like a no-brainer to me, and the technology is definitely coming along. One of the things that we're actually looking at now, though, is how, so V2G is fairly simple, but V2G with load balancing of the grid is the next step, right? And we did a study here in Calgary a couple of years back where, I don't know if you guys know the whole like system of the power grids, but how like these massive power stations, they run to feed the peak current of the grid load, right? So like at 5 o'clock in the evening, everyone comes home, turns on the ovens, TVs, you get this massive peak load. 8 o'clock in the morning, everyone gets up, switches on the toasters, you get a massive peak load. And then it goes down again, then it goes up again, then it goes down again. Well, the power stations have to run to maintain the peak load. And you can't turn them up and down that quickly. It takes 2 or 3 days to turn down the power output of a coal plant. So all the power stations have to run at this peak load. And then all the energy that they don't use in these down areas, they basically just give away. Like in Alberta here, we give away all the energy to BC at night that we don't use, that we create. So there's this massive inefficiency in the system. So we did a study, and if you had vehicle to grid and you were able to use the vehicles to load balance the grid, you would only need 10,000 vehicles plugged into a city of 1 million people to give enough load balancing to take those peaks and chop them right off. That like 30% of overpower disappears. And that's 10,000 vehicles in a population of 1 million. Is enough battery capacity to remove those peaks of the power. That is crazy, because that's huge emissions, right? Being able to cut our power by 30% on the power stations, like right now, with 10,000 EVs plugged into the grid with load balancing technology, right? That's like, that's fantastic. So how do we get there, right? And I mean, it's a huge conversation between power utility companies and electric vehicle companies, and how we create a common language so everything can talk. But it's got to happen, right? Like V2G seems like a no-brainer, but grid balancing has got to happen too.
Well, Nathan, the CCS charging, DC fast charging standard within 3 to 8 years is supposed to have vehicle to grid, which would enable that. And a lot of the manufacturers apparently are saying they will not put software patches on their older gear, their older cars, in order to make it work with the new standard. But it's just software, because the contactors are there to have access from the traction battery to the DC fast charging port. And then it's all the external equipment that syncs it with the grid and charges or discharges. So the equipment's there in DC fast charging cars, but it's just not accessible with CCS. But it is accessible with the Japanese CHAdeMO, but it's not approved for use in the US CHAdeMO. It may never be, we'll see.
Yeah, but the one other one is the Tesla, of course. Yeah, well, we've looked through them and have a Wheatstone bridge or something on their charging system. So the jury is still out if they support vehicle to grid. We don't know yet.
That's interesting. That's interesting. So I think vehicle to grid for sure, but load balancing, that's interesting. Yeah, doing it through the chargers makes sense. That's a good idea. Yeah.
Right, and that's what I was going to say was at least make your car bidirectional on the inverters. So at least you could go the other direction, because that is the easiest way, synchronizing with the grid frequency. I'm sure this is a whole bunch of technical issues to do that. So maybe all you do is provide the power, and the person who wants it may have to buy a separate box at their house that does that syncing to frequency and islanding your house and all that type stuff. Is probably beyond the car. You don't want to build in too much to your car, but at least allow it to go a bidirectional inverter.
Oh, for sure. I mean, having it power your house is a no-brainer, right? If you have a power outage, so that kind of stuff shouldn't even be a point of discussion. But the load balancing stuff is really interesting. It's the same as if you bring a solar farm online or a wind farm online, right? You have to put that into the grid somehow, and it's all got to get balanced. And it's all 100-year-old technology, right? Like the grid is still pretty antiquated. So, but I get the sense it's coming along quickly, right? And the smartness and the intelligence in the grid will start improving. We'll start seeing some. But electric vehicles are going to have a massive part of that. That's cool. Somebody mentioned AC propulsion on their cars, on the Mini E and the T0. So AC propulsion, I don't know if you guys know those guys. They're a big part of the whole EV story. They came out of the EV1 program when it closed down, and they basically kept the technology going. And that was a technology that we ended up putting in the Volvo 3CC, which ended up being used in the Teslas. So there's a whole lineage through AC propulsion being kind of like a cornerstone of the whole EV industry. And Alan Cocconi, who that's what AC stands for, he is an absolute madman, genius guy. Basically invented like the modern motor controllers and like the style motors in the Teslas with the very thin air gap between the rotor and stator. That was all his work. They're an incredible company.
Nathan, I just wanted to add with the vehicle to grid that a number of the manufacturers are putting in just a single outlet for vehicle to load either the pickup trucks so you can run power tools or some of the other cars so you can just plug in like, run an extension cord to the house and run your fridge and a couple of lights in case of a power outage or if you're camping.
Yeah, well, that's just an inverter, right? There's nothing to that. But you're having a bit more efficiency through that system, so you don't get the loss of a crappy inverter, right? Changing that to 120, that'd be good. And the Cybertruck too, yeah. Michael having a nap. Proximity alert for wheels. That's a good idea. That's a good idea, actually. Yeah. That's a good idea.
Will it purr at low speeds so pedestrians can hear it?
Oh, that's silly, eh? That silly rule about noises. Everyone's having fun with different noises too. Porsche's got one now. You heard that one? It's like whoop, 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 kind of a noise. It's really weird.
Well, I will say I drove Leafs. I drove Leafs before I drove a Tesla, and man, I missed it when I went to the Tesla. I love that beep, beep, beep backing up sound. I missed it.
Metal in the frame, we've got steel and aluminum. Yep, a lot of hollow tubing, that kind of stuff. The suspensions, the front suspension is aluminum, the front subframe is aluminum, the rear subframe is aluminum, the rear swing arm is steel. So a bit of everything in there. Jetson knows what the best. I saw a guy who put an MP3 player in his car, like he loads sound clips into whatever his car did. So when he opened the door or whatever, it just made whatever noise he wanted to, and it was a lot of fun. So yeah, I don't see why we couldn't do that. And again, it's all so simple, right? That's like an Arduino. That's a $5 microprocessor to do all that kind of stuff. Data's takeoff. That'd be a good one, eh? The data sound. What's that stand for? Time and relative distance in space. Is that what it is? Noise apps will be good.
Yeah. It's time and relative dimensions in space. Or dimension. There's one dimension in space. There you are.
Thank you, Jeffrey. Appreciate that. Yeah, those kind of apps. I mean, Tesla really, I think, did a great job with their with the fun that they had with the interface, right? And the plaid mode and the ludicrous mode, and just having fun with it. And I think recently about open your butthole, like that was crazy, right? And then I think it was Jason Tolchinsky on Jalopnik is like, well, who said that first? Why did they say it? But it's great they're having fun with it, like they're really just making it and I think that's part of the big appeal of the brand is like they're not taking it too seriously.
Yeah, I mean they've got the more cowbell thing. You can have your Tesla play that, or there's a secret Monty Python thing. Yeah, it's all built in there. Yeah.
No way. Like the Christopher Walken Need More Cowbell skit is in there.
That's it. It's right in there.
My goodness. Oh my goodness. Yeah, the LiDAR thing's interesting, hey? All right, pedestrian sound. Tesla fart sound. Oh, this is great stuff. This is great stuff. Can we sort of wrap it up though? I kind of do have to get back to work here. I'm having a blast, but I do have to get back to work. Yeah, holders value. Yeah, for sure. And again, like we are designing it to last indefinitely, right? That is like with a composite monocoque, if it doesn't get impacted, it's never going to rust. It's never going to anything happen to it. So we really hope that these vehicles last a long time and become a real nice legacy kind of piece. So.
Okay, well, yeah. I'll bring this to an end. Thank you very much, Nathan. I wanted to say a few things. First of all, I'm a reservation holder, and you can go on their website and reserve for, I think, $100. And I think somebody early in the chat gave their referral link where I think you get like $30 off the reservation. Yeah, so thank you very much. This was really interesting.
Awesome. Well, thank you everybody, and have a great evening and have a great weekend. I guess we'll probably talk to you next time.
All right.
Thank you. Thank you.
Thanks for coming, Nathan. We're glad to have your input on this, and it was very informative, a lot of questions, so there's a lot of interest. And one thing I might tell you, you might be able to take back to the team, back in the late 70s, early 80s, I'd have to go back and research through my electric vehicle news magazines, but there was a car that was called a, I think they called it a sail car or something, but it had a aerodynamic arch that was like in the back of the vehicle. And
Yeah.
when you got in the right position, the wind would actually help carry it just like it would be a sail. And so there was some things picked up that way, but that may be a little far-fetched, but if there's any interest at all, I can search that out and at least, you know, find out what it was and where it was and all that sort of thing. But it looked really neat to have this arch over the car that was aerodynamic arch for the wind sail. Another thing I might mention too is there was a question in reference to the EV tax or the gas tax.
Yeah.
There's going to be some changes and stuff.
Yeah.
Just 2 days ago, the state of Colorado in their legislature introduced Senate Bill 21-260. And that is a fairly comprehensive bill. It's 200 pages long. And all of the things that the state of Colorado is going to be doing and how they're going to add a little bit to the gas tax over the few years, how they're going to be adding a little bit to the electric vehicle fee and all that kind of stuff. But you can go to leg.colorado.gov and you can put in that SB 21-260 and you can see a lot of the ideas that they're coming up with in forward thinking as to what they're going to be doing over the next decade. And we had a presentation from the executive director of the Colorado Energy Office, gave us some information on that today on a group in the policy group of the Colorado Electric Vehicle Coalition. So that was kind of interesting.
Cool.
That's where we're going to be kind of going in the future to kind of offset the EVs as they come on board and stuff. But it's a lot of change is going to take place over the next 10 years for sure.
Interesting to see what they talk about grid-wise too, because everyone's saying that like without the EVs coming on board, the grid's going to have challenges, right? So interesting to see what they're thinking about from a grid side too. And you know, Colorado being one of the most progressive places on the planet, I'm going to read that because that would be some pretty good stuff. So thank you, David. I appreciate that.
Yeah, so it's some interesting info there on what they're going to be doing. It all has to go through the committees and pass both the House and the Senate and the House before it actually you know, is made law, but there are some ideas in there anyway.
Fantastic. Well, thank you. I appreciate that. Awesome. Great. Well, thanks everyone.
All right. Thanks, Nathan.
We'll talk to you soon. Bye.
I think we'll just go ahead and wrap this up for the evening. I'm glad everybody showed up that did. And we may have another one of these on almost the spur of the moment events later on, but we do have a vehicle to grid or vehicle to building meeting coming up on Saturday, I believe it's the 15th, isn't it, Julia?
Yeah, the 15th at 10 o'clock. So so there's a nonprofit called the Alliance Center that is actually doing an experiment on vehicle to building in their case. So if you're interested in that topic, May 15th at 10 o'clock.
Okie doke. Well, thanks everybody.